Hello everyone. Today we have a very interesting problem from ISI Entrance 2023, Subjective Problem 5. This one says that there are three types of pieces that you have. A red piece, which is 1 cross 1 square. So this is just a 1 cross 1 square. A blue piece, which is also a 1 cross 1 square. And a yellow piece, which is a 1 cross 2 square rectangle, right? So these are the pieces that you should be using to cover a rectangular piece, which is 1 cross n. So there is one row, and there are n columns, okay? The question has two parts. The first part shows that a certain recursive relation holds, and the second part says that a direct analytic formula also holds. So I will explain both of these. It's a very interesting problem from combinatorial geometry. Actually, it's just combinatorics with a bit of geometric flavor. Okay. All right. So let's get started. So the first question says that suppose Tn, this is part A, Tn is the number of ways of covering 1 cross n rectangle. Okay, so let's say if we have one, so let's compute T1. T1 means we just have one rectangle, one cross one rectangle. Let me draw it in a better way. So how can we cover this 1 cross 1 rectangle, or which is just a square, with these pieces? Well, I can either use the first piece, the red piece, or I can use the blue piece. I cannot use the yellow piece, right? So it can be either red or it can be blue. That's all. So there are two ways. So T1 is equal to 2. Similarly, T2, to do T2, you can just take a 1 cross 2 rectangle. 1 cross 2 rectangle. Now, how can you cover this with the pieces? Well, you can have red, red, blue, blue, red, blue, blue, red, or just the yellow piece, right? You could also have just one yellow piece, which is 1 cross 2. It will completely cover the rectangle. So T2 is 5. There are 5 ways of doing this. Similarly, we can define Tn, which is dealing with a 1 cross n rectangle. Well, with this definition in mind, our claim is that T2n plus 1 is equals to Tn times Tn minus 1 plus Tn plus 1. So the number of ways of covering a 1 cross 2n plus 1 rectangle is expressed in terms of number of ways of covering 1 cross n rectangles, number of ways of covering 1 cross n minus 1 rectangles, and number of ways of covering 1 times n plus 1 rectangles. It's a classic example of a recursive relation. So how do we go about it? I have talked about this numerous times in the combinatorics classes for mathematical Olympiads and ISI CMI entrances, that whenever you see a situation like this should be broken down. First, it should be sort of split in the sum form. And then you should think of each of these as subcases of this. So this is the total number of cases of covering 1 times 2n plus 1 rectangle, and these are the mutually exclusive and exhaustive subcases. So they together make up all the cases and they don't overlap each other. They describe cases which do not overlap each other. Okay. All right. So how do we go about this? All right. So let's see. This is a very nice combinatorial argument. Simple but nice combinatorial argument. So let's look at the 1 cross 2n plus 1 box. 1 cross 2n plus 1 box, rectangle. So there is one row and 2n plus 1 columns. 2n plus 1 columns. Okay. So now let's look at the nth box or nth column. The nth column. I will divide into two cases. Number one, it has the first box of a yellow piece. The nth box has the first box of a yellow piece. So it's like this. The nth box of this rectangle, this particular covering, has the first box of a yellow piece. The second case is the nth box does not contain the first box of a yellow piece. So it does contain, it does not contain the first box of a yellow piece. Of course, you can see that both of these cases cannot happen together, so they are mutually exclusive. And then both of these cases will together make all the cases, because after all, the nth box will either start with a yellow box or it won't start with a yellow box. One of these two things will happen, right? So these two cases will together make up all the cases. Okay, so if it starts with a yellow box, if it starts with a first box of a yellow piece, then let's divide this. Let's divide this. There are n minus 1 boxes to the left. There are n1 minus 1 boxes to the left. And there are n boxes to the right, n columns to the right, n minus 1 columns to the left, and there are 2 in the middle which contains the yellow box, right? So 2 plus n minus 1 plus n, which is 2n plus 1, which is exactly what we have, right? Okay, so the number of ways of covering this n minus 1 times n minus 1 rectangle, this is simply Tn minus 1. And the number of ways of covering this one, the right hand side, this piece, is there are n columns. So this is just Tn, right? And that's by definition. So the total number of ways of this covering, this particular covering, is Tn times Tn minus 1. Tn times Tn minus 1. Okay. The other case, the second case, that the nth box does not contain the first box of a yellow piece. Okay, so now let's make another break. So I will make this break at the nth point. So since the first box is not a yellow piece, I can just consider this as 1 cross n rectangle, 1 cross n rectangle, and just count the number of coverings of this. So this is, I'll just draw it in red. The number of coverings of this is simply Tn. And I can do this because the first box, the last one here, is not the first box of a yellow piece. So this part is a whole in itself. This is Tn. And how many boxes are we remaining? Well, we have n plus 1 boxes remaining, right? N plus 1 boxes here. Again, these two are, we can count it separately because there is not a yellow box overlapping them, because we are in the second case, right? So the number of ways of covering this piece is 1 cross n plus 1 rectangle is Tn plus 1. So this is total number of ways is Tn times Tn plus 1. Okay, so what we have here is T2n plus 1 is Tn times Tn minus 1 plus Tn times Tn plus 1. So that solves the first part of the question. It's very nice how you can split the recursive relation into two pieces and think of them as sub-cases of the main case. So standard strategy, okay? All right, now let's go to the part B of this question. The part B gives an analytic function. It says that Tn is equals to summation d greater than equal to 0, n minus d choose d 2 to the power n minus 2d. Okay. Again, this can be done in the exact same way. So again, you have a sum of things. So you can split them into sub-cases, like each piece will represent a particular sub-case. Let's see how it happens. To understand this, I will just write down T7. Okay, T7, because it will give you an idea about exactly what's going on. So this is 7 minus 0 choose 0 2 to the power n minus 2 into 0 plus 7 minus 1 choose 1 n minus 2 to the power 7 minus 2 to the power 7 minus 2 times 1, 7 minus 2 choose 2, 2 to the power 7 minus 2 into 2, finally 7 minus 3 choose 3, 2 to the power 7 minus 2 times 3. Okay, so this is the last term. So what we have? We have 7 choose 0, 2 to the power 7, plus 6 choose 1, 2 to the power 5, plus 5 choose 2, 2 to the power 3, plus 4 choose 3, 2 to the power 1. That's all. Okay. So what I'm claiming is that this right hand side, there are several pieces and you see the plus signs, right? So it means that each of these pieces will tell you about a particular sub-case of the total number of cases. So you have to just understand what these mean, each of these pieces mean. So the first one is really simple, and so let me just draw it. it's a 1 cross 7 rectangle. So 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. 7 rectangles are here. The first one says use 0 yellow piece. Don't use any yellow piece, okay? Which means you are only allowed to use the red piece and the blue piece. That's all. You are only allowed to use, so you have two choices for each box. For each box you have two choices. So you have total 2 to the power 7 cases. So 7 choose 0 times 2 to the power 7 is the sub case which says that use 0 yellow pieces. Now you see where I'm going with this, right? Now the second one will say that use 1 yellow piece. Use 1 yellow piece. The 6 choose 1 case. So how do I go about that? Well, what I'll do is I will first choose the first. So if there is 1 yellow piece, I will first choose where is the first box of this yellow piece. The first box. The first box of this yellow piece. I'm using only 1 yellow piece. I want to know where I can put the first box of the yellow piece. So the first box of the yellow piece can go to 1, 2, 3, 4, 5, 6 places. The first box of the yellow piece cannot go to the last one because then we will have something like this. It will go outside the rectangle. The yellow piece will go outside the rectangle. So we have 6 choices where the first box of the first yellow piece can go. I have to choose one of them. Now I'm remaining with 2 to the power 7 minus 2 boxes, because of course 2 of the boxes are gone with that yellow piece. So I have 2 to the power 7 minus 2 cases for the red and blue, right? The other 2 to the power 7, other 7 minus 2 boxes, each of them I can fill in with red or blue. So total 2 to the power 7 minus 2 choices for that. So the second case becomes use exactly 1 yellow piece. Now you can guess what the third case will be. Use exactly 2 yellow pieces. Now there is a subtlety here that you have to explain. You see, if I choose any 2 boxes, let's say I choose this one and this one. If I choose any 2 boxes from the first 5 boxes, that will give me a code for where to put the 2 yellow pieces. Listen to this very carefully. If I choose any 2 boxes from the first 5 boxes, those 2 choices will give me a code for where to put the 2 yellow pieces. And what is the code? From the left, wherever you see the first dot, start the first yellow piece there. And wherever you see the second dot, start the second yellow piece 1 box to the right of it. So I saw the second dot here, so I started the second yellow piece 1 step right of it. Now you can play this game and try to understand what I'm saying. Suppose I put the first dot here and the second dot here. So what is the corresponding position of the yellow pieces? Well, the first dot says where the first yellow piece begins. And the second dot says where the second yellow piece begins, that is one step to the right of it. So here. So let me write that. First dot begin first yellow piece there. Second dot begin second yellow piece. One step to the right of the second dot. Now you see, we can only do this from the first 5 boxes, because if I put the second dot here, then the second yellow piece will start one step to the right of it. So it will be like this and it will go outside the rectangle. So that can't happen, right? So from the five boxes, choose 2 of them where to put the dots. And you are now remaining with 7 minus 4 boxes where you will put the red and the blue, where you will put the red and the blue, the red and the blue. So you will have 2 to the power 7 minus 4 choices, 2 for each case, right? Okay, so that's the third piece. And the fourth piece is you are using 3 yellow pieces. 3 yellow pieces. So again, do the same exercise. Let's draw this. So you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So from the first 3, throw away the last 3 boxes. Don't worry about it. From the first 4 boxes, choose any 3. Put 3 dots somewhere. Okay. Now this is a code for where to put the yellow boxes. What kind of code is this? Well, the first dot tells you where the first yellow box begins. Okay, so we have something like this. Now the second dot begin the second yellow box, one step to the right of this dot. So you begin the second yellow dot here, second yellow box here, because you begin one step to the right of the second dot. Now what about the third dot? Begin the third yellow box, 2 steps to the right of this dot. 2 steps to the right. So you go 1 step to the right, 2 steps to the right. You begin here. So you have the third yellow box here. This is extremely important, that the choice of these 3 dots or choice of these 3 boxes how they are translating into the position of the yellow boxes. You have to explain this. Okay. So from 4 positions, you choose 3 dots. And of course, once you have done that, you are left out with 7 minus 6 boxes. And just one box actually. And that you can cover using blue or red dominoes or pieces, right? So therefore you have 2 to the power 7 minus 6 choices. That tells you the last one. So you now see why T7 is just the sum of these 4 cases. Exactly same argument works for Tn. So you can write the exact same argument and prove the identity or the formula for Tn, 2 to the power n minus 2t. So again, in each step, you choose D yellow boxes. Yellow boxes are used in each subcase. The remaining n minus 2d boxes are filled with red or blue. So 2 choices for each of the remaining n minus 2d boxes. 2 choices for each of the n minus 2d boxes. And n minus d, choose d. So you throw away the last d boxes and put d dots in the n minus d remaining boxes. And those d dots will tell you how to put the yellow ones, yellow pieces. Yellow pieces means the 1 cross 2 pieces. Okay. And that's it. So you have the solution, both the analytic formula and the recursive formula for this problem. It's a very beautiful problem. It makes you think and think really into the reason and the argument of what's going on. I hope you enjoyed it. Keep on doing good mathematics. I will see you in the next one.